Hello and welcome to the channel Understanding.Concepts.Of.Physics. Subscribe the channel if you have not done so. Let's just quickly start with our regular topic of oscillations. We have been doing oscillations in some time and this topic is going to take some time to get finished. Now today what we are going to do is we are going to study something about minimum and maximum displacement, what minimum and maximum displacement would be. So it's going to be just a short explanation today. So let's see. We have been doing oscillations in some time and we have reached up to a point where we derived what is called as acceleration. First of all, we derived differential equation. If you can see on the screen, differential equation. Then we derived something called as acceleration. Then we derived something called as velocity, and then we derived something called as displacement. So this was the previous video where we found out the different equations of displacement, where the particle is beginning from. So this equation was valid when the particle is beginning from the mean position and it is going to the right, that is the positive extreme. Then this equation is valid when the particle is beginning from the mean position and going to the left. Then this equation was a particle where the particle is going from extreme to extreme. So this is a negative extreme, this is a positive extreme, and this is the mean position. So this equation is valid when the particle is beginning from this position, the positive extreme, and this is this is the extreme position. So this is a negative extreme and this is a positive extreme. So this equation is valid when the particle is beginning from the negative extreme, and this equation is valid when the particle is beginning from the positive extreme. However, when it is starting from the mean positions to the right, your first equation is valid. When it is starting from the mean position and going to the left, the second equation is valid, and third equation is for this to the right and this to the left. So this is the way how it works. And today we are going to see something about minimum and maximum displacement. It's a very easy topic. Let's just quickly start. So whenever you wish to find out the minimum displacement, you find out the basic equation, that is x is equal to a sine omega t plus alpha. And here I am assuming that the particle is beginning from mean position. So if the particle is beginning from mean position, I can say that when time is equal to 0, the value of alpha is 0 or it is pi. So in the previous video I have shown you how this alpha ka value comes out to be. Then x would be equal to, now if I put these two values in the above equation, so I'll get x as it is, a as it is, sine as it is, omega as it is, and wherever there was t, I'm putting a 0 over here, and wherever there was an alpha, I'm putting a 0 over here. So 0 into anything is 0, 0 plus 0 would be 0, and sine 0 is something I get, and sine 0 is 0, so 0 into a will again go to 0, so I get a displacement x is equal to 0. Now if you put the other value, that is pi, then you will see that wherever there was a t, I put 0, and wherever there was alpha, I have put a pi. So this is 0 into omega is 0, and 0 plus pi is pi, so I get sine pi. Now sine pi is again 0, so you should be knowing that sine 0 is 0 and sine pi is equal to 0 as well. So everything goes to 0, so it means that when the particle is at the mean position, the displacement is minimum, and that comes out to be x is equal to 0. Now let's see for maximum displacement. So again I start with my basic equation, x is equal to a sine omega t plus alpha. When the particle is beginning from extreme position, let's say for the extreme position what we get. So t is equal to 0 is what I am starting with, begins, and alpha ka value is pi by 2 or 3 pi by 2. Now again go back to the previous video to get the values of pi by 2 and 3 pi by 2. This is from the previous video. Now I'll put those values over here. So alpha ka value is once 3 pi by 2 and once it's pi by 2, and t ka value in both the sides is 0. So t is 0, one times pi by 2, the other time is 3 pi by 2. So this is 0, and omega into 0 is 0, and 0 plus pi by 2 is pi by 2. So I get sine pi by 2 over here. Now sine pi by 2, that is sine 90, is giving out to be 1. So this whole value is 1. So 1 into a is a. So this is a. However, if you check this, omega into 0 is 0, and 3 pi by 2 plus 0 is 3 pi by 2, and sine 3 pi by 2, that is sine to 70 degrees, is equal to minus 1. So this comes out to be as equal to -1. So -1 into a is -a. So I've just concluded that into a very short table, that minimum displacement and this is the maximum displacement. So the minimum displacement is 0 and the maximum displacement is either plus a or minus a, depending upon which position you are. So if you are on the positive extreme, it's plus a, when if you are on the negative extreme, it's minus a, and if you are at the mean position, it's 0. So minimum displacement is at the mean position and the maximum displacement is at the extreme position. So these are small cues and conclusions, that displacement is minimum at the mean position and displacement is maximum at the extreme positions, and that is plus or minus a, and that goes to 0. So that's it for this video. Thank you so much for watching. Have a nice day. Subscribe the channel in case you have not done so. Tomorrow we will be meeting again to see how to find out the minimum and maximum velocity, and in the next video we'll be seeing how to find out the minimum and maximum acceleration. So lots of videos are lined up. Just keep watching it daily and you will really come to a point where you have completely prepared the chapter. Keep making notes. Thank you so much. Have a nice day. Bye.